Find the general solution to the linear differential equation that we have here. Okay? So dy by dx, or y prime, or whatever you want to call it, the derivative plus 4 times the original function is equal to 3e to the 2x. Okay. So it's a linear differential equation. The fact that they give us that little tip-off in the question, which is not an uncommon thing, tells us, oh, okay, we have a process for linear differential equations. What do? First, you got to find an integrating factor. I'm more accustomed with my linear DEs to write y prime instead of dy by dx. You don't have to, but... is it 2e to the 3x, or was it 3e to the 2x? 3e to the 2. Okay, I had it wrong. There we go. So we'll have 3e to the 2x. Now, we have y prime by itself. It's a plus sign here, which means this 4 is just our p of x, our coefficient of the original function. So it's just a nice constant. Okay? So the first thing we need, integrating factor, we'll call it I of x, I guess. Right, there's a couple standard names for integrating factor. I for integrating factor seems pretty standard and pretty nice to me. So it's e to some antiderivative of your p of x. So that's e to, what are the antiderivatives of 4? Well, we certainly know it's 4x. Okay. So there's an integrating factor. Now, if we're doing a linear differential equation and we're in a little bit of a rush, we actually don't need to go through all the motions. We can just skip right to the sort of answer. What you should be doing is multiplying everything by your integrating factor on both sides. Okay. And then what happens is, and this is well known, this is why you can skip over this, this whole bit is just what you get when you do the product rule to your integrating factor times the function you're looking for. And then to get rid of the differentiation, right, when you're doing algebra, right, if you were trying to solve for y, if this was an algebra question, you would slowly cancel out the operations by reversing them one at a time. How do you get rid of a plus 1? You subtract 1, so you'd subtract 1. And then you'd be left with 3y. How do you get rid of a times 3? You divide by 3. Well, what do we got here? We got y times e to the 4x differentiated. Okay, let's cancel the differentiation first, since that's the most recent thing. How do you cancel differentiation? With integration. Okay. And then you'll be left with e to the 4xy equals some integral. Yes, there's a reason I have not simplified this yet. Because what I'm trying to say is you can actually just jump straight to the final answer. It's the final sort of result of all this rearrangement and the whole process. Okay, you divide by your integrating factor. And so what you could have done, if you just wanted to go very, very fast and you weren't trying to show your work, you can just jump straight to y equals the integral of your q of x times your integrating factor, all of that divided by your integrating factor. Okay? So let's say we just jumped straight here, even though I guess clearly just showed all my work. So we got y, we got an integral, so we got 3. We got 2 e's. What happens when you multiply things of the same base? You add the exponents, so we get 2x plus 4x, 6x. Okay. So integrate e to the 3e to the 6x. How can we do that? Okay. So we bring the 3 out if we want to. Okay. E to the 6x. What do we get there? Okay, so you'll integrate it, you'll get e to the 6x over 6. If you want to do that a little bit slower, you'd use a substitution. Okay, I'm not going to write it out, but the substitution here would be you'd let u be 6x and you'd go from there. Okay, so we get, so the 3 and the 6 cancel out a little bit, so you'll get e to the 6x over 2 plus c over e to the 4x. I'm going to write the divide by e to the 4x as a multiply by 1 over e to the 4x, and then I'm going to write 1 over e to the 4x as e to the minus 4x. Okay? And then we can distribute that in, and we will get our final answer. So the 6x minus 4x, you'll get 2x. So you get e to the e to the 2x over 2 plus c e to the minus 4x, and that's it. There's our final answer, the general solution to the given linear differential equation.